All right, everyone. Welcome to our first chapter of environmental science, looking at the environment. So when we look at this, first we need to define what the environment is, define environmental science. So when we're looking at the environment, we're looking at that natural world, okay, typically as a whole, but oftentimes we're just looking at geographical regions. So we might be talking about the Arctic tundra, the tropical rainforest, coral reefs, and that's that one specific environment. Or again, we could be looking globally at the whole environment and how all of these different smaller geographical areas interact with one another. And then we are really looking at the impact of human activity. Within environmental science, okay, this is interdisciplinary. So we've got all sorts of fields of physical sciences, biological sciences, information sciences to process all the data that's collected, to look at the environment, the impacts that humans are having, how these environments function naturally, how they're functioning in the face of things like pollution and habitat destruction. And then a big part of environmental science is also how we fix some of these problems, or at the very least, mitigate the impacts that we're having, kind of limiting what we're doing bad to the environment. The major goal of of environmental science, understand and solve environmental problems. Right? We see things that are happening all of the time. One of the big things you hear about all the time now is colony collapse disorder within honeybees. So we have scientists that are studying this, trying to figure out what the root cause of this is, because they're super important for agriculture in pollinating the crops that we grow. So it's important that we solve this environmental problem that we're having so that we can continue to feed people. So within this, we need to figure out how ecosystems work. So what is it about a tropical rainforest that allows it to sustain itself? Right? What changes do we make that no longer allow it to do so? How do organisms interact with each other? Big part of this is introduced species. So when we introduce something like rats to an island, what happens to that environment? When this new generalist species is there that has no predators, we see lots of issues occur. Function of climate systems. This one's huge, right? You can't go a day without hearing about climate change. So trying to understand how these systems work on a large scale, and then trying to make predictions based on what we know, give us a good idea of what's happening now. And if things continue to change with our atmosphere, what could happen in the future. Cycling of nutrients through ecosystems, global nutrient cycling. We upset this in many ways by introducing synthetic nutrients, by disrupting flows of rivers and lakes and things like that. And so how does that impact natural ecosystems? Okay. And then again, huge part of environmental science, right? This wasn't a field of study 200 years ago. Because we didn't have as large of an impact on the environment at the time. But now there are nearly 8 billion people on the planet. Most places in the world are pretty industrialized. And so we have huge impacts on these natural ecosystems. And so environmental science looks at these impacts and then looks for solutions. And these are alternatives to our current actions. So we use a lot of timber for things like paper. What are the alternatives to that would be less damaging to the environment? We burn a lot of fossil fuels for energy. What are the alternatives to that might have less impact on the environment? And so these are just various ecosystems. The earth is incredibly diverse. The living things that inhabit these areas are incredibly diverse. So there is no one solution because all of these places are so different. The way that they function is very different. Our impacts on them are very different. And so there is no clear-cut solution that's going to work for all ecosystems. we really have to find a balance for all of these different areas of the resources that we get and the damage that we're doing, and making sure that we are not completely destroying them in the process. And this looks at that interdisciplinary aspect of environmental science. Right? We've got all of these things: history, engineering, economics. Economics is going to be huge in this, as well as politics, because we see that there are loads of solutions to environmental problems, but if they cut too deeply into profits, we are not going to see those solutions come to fruition. So we see a lot of that. And then, of course, we've got our hard sciences, our biology, chemistry, geology, physics. All of these things are part of this as well. That's the real data collection. This is how things are happening. And then we've got the human side of it, kind of on the left side of that circle of what are we doing, what's our impact, and what are the trade-offs that we're willing to accept. Looking at human perspectives on the environment, we've got a few different perspectives that we have had in the past. These perspectives still exist within people, and none of these are mutually exclusive. You can hold more than one of these perspectives at the same time, and no government or culture or group is set on one of these. And no person is set on one of these. They change as they grow. We look at pragmatic resource conservation. This is Teddy Roosevelt. He got this from Gifford Pinchot, his advisor. And basically, this is utilitarian conservation. And our quote here is, "For the greatest good, for the greatest number, for the longest time." Basically, we're going to use the resources that exist naturally, but we want to manage them in a way that we can get as much benefit out of them as possible for as long as we possibly can. Okay. So here in pragmatic, we're looking at this as these things exist for humans and we're going to use them, but we need to manage them as we use them. Okay. And so we look at multiple use policies in the United States Forestry Service. And so multiple use is, we've got this for tourists and campers and hikers and bikers, right? These national parks. So we get benefit there. We have ranchers come in and their livestock will graze these areas some part of the year. And so we're getting lots of different uses out of these areas, and we're going to manage it in a way that we can do it for a very long time. Looking at moral and aesthetic nature preservation, we can look at the Sierra Club. Nature deserves to exist for its own sake. It's there. It deserves to be there. It will always be there if we're there or not. Its usefulness to humans should not define whether or not a natural area should be preserved. Right? So we look at deserts, not a ton of use to us. That does not mean that they shouldn't exist under this moral and aesthetic nature preservation. Okay. This is very biocentric preservation. That's kind of a subset of this moral and aesthetic. Why ought man to value himself more than the one great unit of creation? So why should we as humans believe that nature is a commodity to us, that it's just part of our economy when it's been here longer than us, right? It's the reason we exist. And so that's what we look at here, moral and aesthetic. And something that we look at here within this is there have lots of court cases related to the environment. And one of them was Disney wanted to build a ski resort in the Rocky Mountains. That are the Sierra Nevadas. I can't remember. But they were sued because this area deserves to exist naturally. Why do they think that they can just destroy this portion of this mountain for a ski resort so humans can ski? Turns out it just cost them too much money and they gave up on it eventually. The land ethic, we abuse land, we regard it as a commodity. Okay, not a lot of moral aesthetic nature preservation there. Okay, so that'll end the first video here. We'll jump back in to our third viewpoint here in our second video.